Okay, Chaniti and Ransiluni gave the answer. What about the others? 12th MCQ. It's 12th MCQ. So I'm getting different answers. So some of you gave it fourth answer, some of you are given the third answer, fifth answer. So actually you have to compare the electronegativity difference. Which one has the highest electronegativity difference? Minimum covalent properties. Minimum covalent properties, put an arrow and write. Minimum covalent means higher, most ionic. You can see this in most ionic. Most ionic. So all these are covalent bonds. Covalent bonds. Which one has the highest electronegativity difference? So actually the answer is third, HF. The reason, now you can see actually you have learned about hydrogen bonding. HF electronegativity difference, so fluorine 4 and hydrogen 2.1. So iodine is 0, the difference. Non-polar 100% pure covalent, non-polar covalent bond, and NCl also approximately equal. Then OF, so this is 4 and this is 3.5. And phosphorus and hydrogen also very low difference, so that phosphorus is even lower than nitrogen, so the gap is less. So the answer is 3. So you get here HF, the difference will be 4 minus 2.1. Then you get 1.9, right? 1.9. So the highest electronegativity difference, most ionic means highest electronegativity difference. Highest, I put EN, electronegativity difference. So out of your answers, 12th one, Ransilon, your answer is correct. Others, did you all understand? Chaniti, your answer is correct if they have asked maximum covalent properties. Then the answer is 4. Understood, Chaniti? If they have asked maximum covalent properties, then the answer is 4. Most covalent. Then Megha Dulshan. Dulshan also put the fourth answer. So did you understand, Dulshan? Now, if they ask maximum covalent properties means lowest electronegativity difference. So electronegativity difference 0 means pure covalent bond. Zainab, you put the fifth answer. You can check the electronegativity table. So approximately is 3 equal, like actually there's a slight difference. Chlorine and nitrogen, so almost 0, almost 0. Right. Okay, then let's move on to the next question. Question number 13, I'll erase the screen. 13th MCQ, in which one of the following the first ionization energy lowers? First ionization energy highlights, lowest highlight. Answer is yes. Can you quickly post the answer to the chat? Okay. Megha Dulshan, your answer is correct. Shamika correct. Ransiluni correct. Okay. Actually, first ionization energy lowers. Group 1 bottom. First ionization energy lowers what? Group 1 bottom. Group 1 bottom. Group 1 bottom. So that is francium. Answer will be francium. Lowest group 1 bottom. Group 1 also bottom. If they ask highest, highest value will be group 8 top. Actually in your A level periodic table we call it group 18. We don't use even Roman number under new syllabus. We use the US convention group 1. So then highest will be group 18. Group 18. Right. Group 18 top. Lowest group 1 bottom. So those who have given the fifth answer, Chaniti, potassium, actually francium is even below potassium. That's the reason, right? If you only can, I'll use the white background to explain the answers. Okay. So what are the, that's why I told you have to be familiar with the periodic table. Right. So this, I think this also as I remember, this is LL passport question. Group 1 bottom. Lithium, hydrogen, lithium, sodium, potassium, lithium, sodium, potassium, rubidium, cesium and francium. Right. Rubidium, cesium and francium. So anyway, you are given the periodic table and you don't need to worry. So down the group, first ionization energy decreases. Any group down the group, first ionization energy decreases. So the answer will be fifth answer. Only Dulshan, Chamika and Ransiluni gave the correct answer. Only Dulshan, Chamika and Ransiluni gave the correct answer. Right. So I'll erase the screen. Question number 14. Shape of the PF4 plus. PF4 plus. Now, if you take PF4 plus, can you quickly post the answer to the chat? PF4 plus. Around phosphorus there are 4 fluorine atoms, so there are no lone pairs. So then what is the geometry? 4 bonding pairs. So right, according to VSC PRT, valence shell electron pair repulsion theory, around phosphorus 4 bonding pairs, 0 lone pairs. 4 bonding pairs and 0 lone pairs. Then what is the geometry? Remember in the exam, if they give just the shape of the molecule, then it's like molecular geometry. 4 bonding pairs, 0 lone pairs. 0 lone pairs. Around phosphorus. Okay, let's see your answers now. Question number 14. Answer is 3. Ransiluni correct. Dulshan correct. Chaniti and Jamika, you have put the 4th answer. Why? Trigonal bipyramidal, no lone pair. So phosphorus outermost shell 5 electron. Phosphorus 5 outermost shell 5 electron. Right. 4 fluorine contribute 1 electron each. You can check the number of pairs. So how to do this easily? If you get this in essay type, they will ask you to, or structured essay, they will ask you to deduce the shape. Then you write around phosphorus 5 valence electron. Right. Then 4 fluorine atoms contribute 1 electron each, then 4. For the positive charge, 1 electron is lost. Then what is the total electrons here? 8. So 8 divided by 2, you get how many pairs? 4 pairs. Out of 4 pairs, all 4 are bonding pairs. All 4 bonding pairs. Four bonding pairs. Then nothing left as lone pairs. 0 lone pairs. Understood? Please raise the hand, those who have not done the molecular geometry or the shape of the molecules. If there's anyone who has not done this. Zainab, you have not done. Others we have done, right? Theory? Okay. Right. Okay. Don't worry, with time you will get it, Zainab. I'll explain. Right. So when there are 4 bonding pairs and no lone pairs, so that is called tetrahedral. That means if you take one of the best example, normally even in even O level you have done CH4 like this, ne? But actually it's 90 degrees. But if there's any other orientation which can make the, so 90 degrees means the repulsion bonding pair BP repulsion between bonding pairs. So this bonding pair also 2 electron, this bonding pair also 2 electron. Between these bonding pairs there's a repulsion. So that repulsion here 90 degrees, the angle. Right. But if you have like this kind of one, this one you can write here tetrahedral geometry, then it will be what? 109.5. So this one the angle will be 109.5. You can even search in the internet, three-dimensional view or molecular. There are some softwares. I'll share that with you. The link I'll post to your WhatsApp. So there are some basic, chem sketch software. You can like online, no need to install or download. Even you can online. You can put the number of atoms and you can ask them to optimize or the most stable the arrangement. Then you get the molecular geometry. So CH4, so that is 109.5 when it's 109.5. So 109.5 the repulsion is less than when it is 90. 90 the repulsion is more. So when the angle is more, the repulsion is less. So when the repulsion is less, so that is more stable. When there's more repulsion, then it's unstable. More energy, more repulsion or more attraction. Both are unstable. So when the attraction and the repulsion gets balanced, that is the most stable configuration. Right. Then next one. Any questions you can ask? Okay. So the answer is what? Tetrahedral, right? Answer is tetrahedral. Tetrahedral. So electron pair geometry also tetrahedral, molecular geometry also tetrahedral, right? Because no lone pairs. When there are no lone pairs, molecular geometry is equal to the electron pair geometry. If you only write that short note, right? That means arrangement of electron pairs around the central atom also in PFO it's tetrahedral. Molecular geometry also tetrahedral, right? The next part. On question number 15, which one has a maximum boiling point? Can you quickly post the answer for the 15th MCQ? 15th MCQ, what is the most correct answer? Any volunteers? You can quickly post the answer to that. Maximum boiling point. Others also hurry up. Okay. Correct answer is actually what are the factors affecting the boiling point? Okay, only two of you gave the answer. Ransiluni and Dulshan. Question number 15. What? Okay, please write. Forget about the answer. First, let's see the factors affecting the boiling point of covalent compound. Factors affecting the BP. BP means boiling point, right? BP of covalent compounds, not lattices, covalent compounds like molecule. Number one, strength of intermolecular forces. Strength of intermolecular forces. Second factor, number of intermolecular forces. Number of intermolecular forces. Third, relative molecular mass, RMM. relative molecular mass. Right. Out of these, let's see which some compounds relative strength of relative molecular mass become more significant than the other two. When you compare some compounds, number of intermolecular forces become more significant than, sometimes more than one factor can affect, sometimes all three factors can affect. So example, if all the molecules are nonpolar, the intermolecular main factor will be RMM. I'll tell one example: fluorine, chlorine, bromine, iodine, all are covalent. Fluorine, chlorine, bromine, iodine, all are covalent. Which one has the highest boiling point? Down the group boiling point increase. Why? Relative molecular mass increase, right? Not the strength of the intermolecular force. All are non-polar, so weak attractive forces or dispersion or London forces. Number of intermolecular forces can increase, and RMM increases down the group because molecules become larger. Right? Now that is in the same group, but here they have given molecules from different groups, so like different heteroatomic, right? So here the most important thing, I don't know how many of you had learned about this hydrogen bonding. HF has hydrogen bonding and H2O has hydrogen bonding. Why? Because HF, all these contain one common thing you can see, all these contain hydrogen. All these contain hydrogen. So hydrogen is common to all these five answers. Then what matters? The other compound the other element electronegativity matters. So out of this, which one has the highest electronegativity? Fluorine. Fluorine 4.0. Second highest 3.5 oxygen. So then third highest nitrogen 3.0. 3.0. The other sulfur and phosphorus less than that. Therefore the most polar one is HF. So therefore HF has hydrogen bonding. Among HF, strong intermolecular forces are present. Strong intermolecular forces, we call it dipole-dipole interaction. When the electronegativity difference become very high, then we call it hydrogen bonding. So between HF molecules, there's a hydrogen bonding. Hydrogen bonds are very strong with compared to the other intermolecular forces. Then next one is water molecule. Among water molecules also, what there are strong intermolecular forces. Among water molecules also there are strong intermolecular forces. So OH bond is, so this is 3.0, this is 2.1. So this polar delta minus here and here delta plus. Understood? So then there are strong intermolecular forces. Both these contain hydrogen bonding. Now the next problem, now we know the most polar ones, HF and H2O, because of the highest electronegativity difference. Now out of these two, which one has boiling point? How to decide that? Out of these two, both form the same strength, the hydrogen bonding, both the strength of intermolecular force same, right? This is called hydrogen bonding. Hydrogen bonding. Right. Now let's see, out of these two, which one has the highest boiling point? Water or HF? Water or HF? H2O. Why? Water has higher boiling point than HF because it can form more intermolecular forces. Because this side also there can be a 1. This hydrogen also can form 1. This oxygen also can form like this. Around one water molecule there can be 4 hydrogen bond. But HF cannot form more than that. HF cannot form 4 hydrogen bond. So since there are 2 OH groups, each side hydrogen bond can be formed. Each hydrogen can get attracted to adjoining water molecules. So therefore highest boiling point water. Highest boiling point water. Why? The strength plus the number of hydrogen bonding form around the water molecule. Both will affect. So who has put the, so what is the answer? Then final answer will be question number 15. The answer will be 4th. Answer will be 4th. So Chamika correct. Sorry, 15th one. Only 2 of you gave the answer. Dulshan, your answer is correct. Ransiluni answer is not second. It's 4th. What about the others? Others, they haven't done it. So hydrogen is common to all. So which one? What is the factor? The other factor that affect the polarity, or whether it's more polar or less polar. So the other element. So fluorine, oxygen, nitrogen, like that. That's how you should compare. Any questions? Now here the main factor is not the relative molecular mass. Otherwise, water is the here the almost lowest now. Ammonia is 17, water is 18. Relative molecular mass low with compared to the others. Like HF, ammonia, H2O. Like actually H2O is 18. HF as I remember is fluorine. I have given you the periodic table also. You can refer that relative atomic mass, and the UPSC periodic table also I have given you. You can check the RAM or anything here. Fluorine is 18 point, that's a 19, no? 18.9. 18.9 means 90 fluorine. But anyway, in the exam, don't worry, this one is given, no? With any question, the relative atomic mass RAM is given. So fluorine 19. 19 plus 1, 20. 19 plus 1, 20. So 20, HF 20. Then ammonia is 17. Almost like not big difference, RMM total. But actually H2S is heavier. It's a gas. H2S 34. Right? H2S 34. pH3 also phosphorus 31. So it's become 34. So actually water is a liquid, and the others are gases. All these are gases. The second lightest molecule here, water, but it's a liquid because of more intermolecular forces plus they are strong plus more. So therefore what is the main factor that affect here when you compare this? The first two factors will affect. First one and second one will affect. Not the third one. Third one is not significant here. Is that clear, everyone? Any doubts? You can copy it on. Actually, when you are answering this, the most important thing is not the answer. Try to learn something new from each MCQ. Then only it will be useful for the exam. Then shall I erase this? Anyone still copying down this? Done. Shall I erase? Let's move on to the next one. Question number 16. CNO and F, the electronegativity. Okay. So what can you say about the carbon, nitrogen, oxygen, fluorine electronegativity? Yes, can you quickly post the answer to the chat? Electronegativity of this. Decrease or increase or question number 16. Only Chaniti Ransil. Okay, for figure the answer right. Let's see. Decrease from carbon to fluorine. Increase from carbon to fluorine, remain constant. Decrease from carbon to oxygen and then increase. Increase from carbon to then decrease. It should be decrease, no? Yeah. Anyway, most of you are given the correct answer. Carbon is 2.5. I'll write the electronegativity values. Anyway, you are not supposed to memorize them. Carbon 2.5. Okay. Nitrogen 3.0. Oxygen 3.5. Fluorine 4.0. So it increases, right? Increases from carbon to fluorine. It's very easy. Question number 16. Answer is second. Answer is second. All of you are correct. Very good. Those who have posted the answer, Ansiruni, Chaniti, Chamika and Dulshan, your answers are correct. Only 4 of you have who has not put the answer. Saina? Right. It's okay if you have missed any of this. If you couldn't do, like, quickly now read the question and try to post the answer to the chat at least. Answer is second. Very good. Question number 17. Which one has zero dipole moment? Okay, that means, okay, let's see how to decide this one. Question number 17, what is the theory behind this? So can you quickly post the answer, those who have got this? Because I am asking to post the answer, then I can understand your level of your standard, I mean the level of understanding, up to which extent you have learned it, or you have understood. So then you can, based on your answers, I can decide up to which extent I should explain this. That's right. Okay, right. Dinathan, no problem. Right. Okay, Zainab, no problem. Right. Okay. Is that clear what I explained? Now, electronegativity 16th lesson is not hard. Anyway, 17th MCQ, can you check? 17th one, zero dipole moment. Having zero dipole. That means each bond can be polar, but the overall the molecule is non-polar. So there can be molecules. Some molecules bond is polar. Molecules with, okay, it can be like this. Molecule can contain polar bond. I'll tell you this. Polarity, if you take the polarity here, polarity, polar bonds, some molecules contain what? Polar bonds. Bonds also polar, molecule also polar. Bonds polar and molecule also polar. Molecule also polar. Molecule also polar. Then the other instance, there are some instances you get bonds are non-polar, bonds non-polar, molecule polar. Bonds polar, molecule also polar. Next one, bonds polar, molecule non-polar. Molecule non-polar. Each bond is polar, but overall the molecule is non-polar. So let's say I'll give one example here. If you take H2O, H2O nicely match with this. H2O, the bonds also polar, OH bond is polar. Right? One example, here the example. Example H2O. OH bond is polar and H2O also polar molecule. H2O is polar molecule. Understood? OH bond is polar and H2O also polar. And let's see the other category, bonds polar but molecule is non-polar. I'll give one example, carbon tetrachloride, or else CO2. CO bond is polar but CO2 molecule is non-polar. CO2 molecule is non-polar. And the other third one, number 3, third category, I'll put 1, 2, 3 here. Please copy down this because I don't think you will learn this under theory like kind of this kind of not, because you learn this separately. So but it's integrated in the exam. Everything combined. Now the third category, bond also non-polar, bond non-polar, and molecule also non-polar. Please copy down. Both are non-polar. Polar, 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 non-polar, non-polar, non-polar. Then you can ask what can we have the fourth one? Then bond become non-polar, molecule become polar. That is not possible, right? That is not possible. Only these 3 instances you get. I'll give one example. So the carbon dioxide, I'll give 2 examples for the second one. The other example I will give, each bond is polar and the molecule is non-polar. Say carbon tetrachloride, CCl4. So because it get cancelled off. See, there are 4 CCl bonds and each bond is polar, but overall molecule is non-polar, and the dipole moment is 0. It's like the resultant force, something like resultant force, or CH4 also something like that. I'll give a separate summary also with regard to the shape of the molecules, also how to decide this. Then third one, bonds non-polar, molecule also non-polar. One example, the homodiatomic molecule. If you take H2, example H2, the bond also non-polar, molecule also non-polar. Is that clear? H2, the molecule also, each bond is, HH bond is non-polar, molecule also non-polar. Hydrogen molecule is non-polar. So the dipole moment is 0. Is that clear, everyone? Please copy down this. These are the three possibilities. So some of the symmetrical molecules with polar bonds, are non-polar. Polar identical bonds. Symmetrical molecules with polar identical bonds are non-polar. I'll give that summary separately. Please quickly copy it. Now everyone should maintain a separate CR book for the short notes. Paper class short notes. Because that's not a formal note, but it's like integrated one. Okay, please raise the hand. Those who are still copying on this. Shall I raise? Right, done. So I'll erase this. Anyway, if any one of you want to listen to this recording again, like now anyway I will be saving all the recording, paper class recording. Sometimes it will be useful after maybe it's 6-7 months, after about 6 months, so you can't remember now the first part, the first year work or general chemistry, some lessons, so some of the parts then you can quickly refer that. I'll upload this to a separate channel, YouTube channel, and then I'll keep them ready. Not now also, like after the class, if you want to listen to that again, then you can send a request. I joined, but I want to listen to that part again, like then I'll send the recording, no problem. But later it will be more useful, right? Okay, so I'll erase this. Okay. Now one more thing I want you to understand. These some molecules, some symmetrical molecules, some symmetrical molecules, with polar bonds. Molecules with identical polar bonds. This word is very important. Identical polar bonds. Polar covalent bonds, some symmetrical molecules with identical polar covalent bonds. Are non-polar. They have identical polar covalent bonds. Polar covalent bonds are non-polar. Okay, let's see. I'll give some examples for this. Molecule is non-polar, but it contains identical polar bonds. I'll give those shapes, or else I'll make this the shapes of the molecules. I'll give shape wise, the shape of molecules with identical molecules. So this shape, number one shape will be linear, right? Linear, that is carbon dioxide. Carbon dioxide is linear. Its CO2 is linear, because this is the most stable arrangement. Bond angle 180 degrees. Here the bond angle is 180 degrees. So if you keep the bond angle 90, then is less stable. The most stable arrangement will be CO2. So carbon, bond angle 90. Second one, number 2. So therefore this is called linear one. I'll write the shape. Number 1, linear shape. Example, I'll write CO2. And this is the arrangement. Now lone pairs around carbon, so the bond angle will be 180. Okay. Second one, if you take trigonal plane, that means BCl3. So this is like you had done even in physics. So equilibrium of three inclined forces, three non the equilibrium or the resultant of three coplanar forces, non-parallel ones or inclined forces. So each bond is BCl bond is identical polar covalent bonds. BCl3 has identical polar covalent bonds. So this word is very important. All the bonds are identical and they are covalent. But the shape also will affect. Here the shape matters, how they are arranged. So CO2 also has identical polar covalent bond. BCl3, all three bonds are identical. But because of the geometry, because of the shape also, that also will affect to the polarity. BCl3, it's 120 degrees in the angle. 120. So the resultant will be 0. If there are three forces like this, the resultant force will be 0. Then the dipole moment will be 0. I put here dp will be 0. Dipole moment 0. Right. Then next one. The other shape I'll write here. Except I think saying about all this, the molecular shapes. Please raise the hand those who have done the molecular shapes, the shapes of the molecules. Please raise the hand those who have done the shapes of the molecules or the molecular geometry, electron pair geometry, VSC, PRT. Only two of you. Three. Chaniti, Shamika. Okay. Right. Okay. Good. So most of you are done. Right. Then you can get it. Then third one. So that means all these, the dipole moment 0. Molecule is non-polar. Polar bonds, but molecule is non-polar. Third example I'll give you. Third, the molecular shape with this 0 dipole moment. Trigonal plane. Then tetrahedral. Tetrahedral, I told you CH4. So trigonal plane I put BCl3. BCl3, and it's like this. Right. Then this one tetrahedral I put CH4. The bond angle 109.5. Right. Then next one, number 4. Trigonal bipyramidal. Those who have not done the molecular geometry also, please copy down this because you will not learn this sometimes. This the summary not very important. After doing the theory, if you look at this, it will be very useful. So I'll give one example here. PCl5. PCl5, three bonds are equatorial like this. The horizontal plane. Above the plane, one bond. Above this plane, one bond, and below this plane, one bond. Like this is the. I'll correct this with dotted line. So this is the horizontal plane, equatorial. Above the plane, you get chlorine again. Below this plane, fluorine. So this horizontal plane, equatorial one, the angle 120. Then axial one. Axial means the vertical one, and the horizontal one 90 degrees. Then below one also vertically down. That one and the horizontal one 90 degrees. So this all this dipole finally get cancelled off. And the PCl5 is non-polar molecule. PCl5 will be non-polar molecule. So the axial one 190 degrees. So it's opposite to each other. And this get cancelled. So PCl3 in the middle also, the horizontal one also get cancelled. So that is trigonal bipyramidal. So how it become trigonal bipyramidal if you combine like this? So it's like a pyramid. It's a pyramid, right? This is the upper pyramid. So below this you get pyramid, then this is called bipyramidal. So this is trigonal bipyramidal. Those who have not done. So this way also you can make a pyramid downwards like this. Is that clear? Right. If you write the search in the internet trigonal bipyramidal, you will get it easily, the three-dimensional view. Then number 5, the fifth one, square pyramidal, square plane, square plane XCF4. XCF4, there are 4 bonds horizontal, I mean the equatorial flow forward. So here also what happened, the dipole moment 0, molecule is non-polar, then so this 90 degrees angle. Then the other one you can write octahedral. I'll write example SF6. I will write in copy down this under molecular geometry short. So how the relationship between, because you learn in the syllabus the shapes of the molecule separately and polarity separately, electronegativity separately, so in different lessons, but at the end they will make a soup like this. If you take angular molecule, all okay. The other list I'll give. These are what? These shapes with identical bonds. All these shapes: linear shape, trigonal plane, tetrahedral, trigonal bipyramidal, square plane, octahedral. All these shapes with identical bonds. So what is the condition here? All the bonds should be identical. They are polar but identical bonds. I'll give one example. If you make this CH4 to CHCl3, if I make this CHCl3, then one bond is different, hydrogen, and then the other 3 will be chlorine, then it will be what? Then it is not non-polar, right? Bonds are different. One bond is different, CH bond is different from the other 3. Then what happened? Bonds are polar, molecule also slightly polar. If it is CCl4, molecule is non-polar because all 4 bonds are identical. CH4, methane, all 4 bonds are identical and it's tetrahedral geometry. So that means what? Tetrahedral molecular geometry. Molecules with tetrahedral shape with identical bonds are non-polar. Molecules with linear shape with identical bonds are non-polar. Trigonal plane molecules with identical bonds are non-polar. Dipole moment 0. That's what it means. Tetrahedral shapes, the molecules with identical bonds are non-polar. Square planar shape, molecules with identical bonds are non-polar. If you change one bond, then it will change, right? Example CH4 to CHCl3 or chloroform. Is that clear? Right. Then octahedral I gave SF6, sulfide hexafluoride, SF6. Someone asked about that octahedral. The example is SF6. I know. I'll draw this one if you want. SF6 it looks like this. There will be 4 bonds in the horizontal plane, above the plane 1, below this plane 1, like that. Is that clear? Above this plane 1, if I do like this, so this is fluorine. So above this plane I'll put the red one, fluorine, below this plane fluorine. So that is SF6. So that is the horizontal one, the resultant get cancelled. Axial one, vertical one also, the resultant get cancelled. Fluorine is more electronegative, but finally the net resultant will be 0 or the 0 dipole mode. The dipole will be 0. That means each bond is polar, but the molecule is non-polar. Is that clear? Okay. Then next one. So this is the relationship between that, correlation between the shapes and the polarity of the molecule. Right. So shall I erase this? Anyone still copying down this? Please raise the hand. Done. Okay, I'll erase this. Let's move on to the next question. Okay, what is the answer for this now? Now everyone should be able to give the correct answer for this. Which one has a 0 dipole moment? Identical molecule, the molecule with identical bonds. Which one has identical bond? All the bonds are identical. one of those shapes. It should be one of those shapes I have given you. It should belong to one of the shapes. So let's see, I think only 3 of you gave the correct answer. Answer is first one. But that theory is important when you answer in the other questions in the upcoming one. Answer is very easy, so it's the first answer. Most of you have done it well. Then question number 18. You have done the ionization energy, right? General chemistry. First successive, okay. Quickly post the answer. Those who done the 18th MCQ. So they have given how many ionization energies you have. There's a big jump. Check the one with big jump. Then you can find to which group it belongs. To which group it belongs, you can easily find. So therefore, one by one, how many electrons removed now? 1, 2, 3, 4, 5, 6, 7 electrons removed, no? 7 electrons removed now. So removal of which electron? There's a big jump involved. 6 to 7, no? 5 to 6 or what? Until 5th electron. First 5 electrons easily lost. Now you can see after that there's a big jump from this to this. Big jump. What does that mean? This electron has been removed from inner shell. That means this electron. I'll put an arrow on, right? So this is one removed from inner shell. Removed from inner shell. The first 5 electrons removed from the outermost shell. Please mark that if you want, because the gap is not that different. Like the difference is less. So right here the first 5 electrons removed from inner shells. Inner shells. So outermost shell. 5 valence electrons. 5 valence electrons. Then you can easily understand to which group it belongs. 5 valence electrons. That's why those 5 electrons are easily given out. Less energy required. But for the removal of 6th electron, removal of which electron? Now 1, 2, 3, 4, 5, 6, 6th electron. 6th electron. Removal of 6th electron involves a lot of energy. That means 6th electron has been removed from inner shells. This is from 5 valence electron, outermost shell. Valence electrons are present in the outermost energy level or outermost shell, and 6th electron has been removed from inner shells, from inner shell. That's why it requires more energy. Now by looking at the successive ionization energies, you can decide to which group this element belongs. To which group this element belongs. So the first 5 electrons removed easily. The gap is not that big. Therefore, this element should belongs to which group? Group 5. Group 5. So remember, 6th ionization energy highest means it belongs to group 5. I'll give a summary if you want. You can copy down this way also. So I'll give this summary. Ionization energy and ionization energy. Highest ionization energy. A big jump. Highest ionization energy. And then you can tell group. Okay. So highest successive ionization energy gap. Highest successive ionization energy gap. Yeah. So if the removal of electron, say first electron, most difficult to remove the first electron, that element should belongs to which group? Group 8. Removal of first electron is very difficult. That means first ionization energy highest. Right. First ionization, if you want, I'll put here highest ionization energy. That also you can write here. Highest ionization energy. If first ionization energy highest, it belongs to group 8. Right. If second ionization energy highest, it belongs to group 1. Second ionization energy highest. That means it belongs to group 1. third ionization energy highest. The removal of there's a big jump for the for the removal of third electron. Then it belongs to group 2. Fourth ionization energy highest. Then that element should belongs to group. That means first 3 electrons lost easily. No? First 3 electrons lost easily. The answer will be this. Then fifth ionization energy highest. That means removal of fifth electron is more difficult than the first 4. That is group 4. So group 4 top. Then removal of sixth electron is most difficult. Removal of sixth electron most difficult. That means the first 5 electrons lost easily less energy. That means it belongs to group 5. Sixth ionization energy highest means it belongs to group 5. There's a pattern here, right? First highest group 8. Second ionization energy highest group 1. Third ionization energy highest group 2. Fourth ionization energy highest group 3. Fifth ionization energy highest group 4. Sixth highest group 5. Then seventh highest group 6. Right. Then eighth ionization, removal of eighth electron most difficult from the seventh group like that. Then again you get again the same cycle. So this also bit important. Please copy down this. So therefore first ionization energy highest group 8 top. Group 8 top. Helium. Now when this come to the second ionization energy has group 1. Group 1 also what? Top or bottom? Top. Like that. Is that clear everyone? That means second ionization energy has lithium. Because hydrogen you can't talk about the second ionization energy because it has just 1 electron. Is that clear everyone? Any questions? Right, let's see the answers now. To which group it belongs? Group, you got the answer group 5, no? Fifth group. Answer is 4th, no? Question number 18, answer is 4th. 18 answer is 4th, Ransiloni correct. And Chaniti correct. Dulshan, you put the second answer. Second answer is third group. Why did you predict third group here? Okay, if you can tell me the logic you have used, then I can fill the gap. I can tell which part you have gone wrong here. Then question number 19. I'll erase the screen. So now in the revision class you have to refresh your theory knowledge. Plus you should know how to pay attention to the question word, and you get that practice also. Question word before you write the answer. The question word is important, an active word important. Otherwise you will do careless mistake definitely. Question number 19, who can give me the answer? Nature of bonding in graphite. So you have done this in oral chemistry also. Bonding in graphite. Graphite is what? Homoatomic covalent lattice. So you can put an arrow towards graphite, right? Homoatomic similar atoms. Homoatomic covalent lattice. Homoatomic covalent lattice. Carbon save element. Now nature of bonding is what? Okay, you can give me the answer for this 19th one. Answer is Chaniti correct, Dulshan correct. Okay, answer is nature of bonding in graphite will be covalent bonds. Covalent bonds. Graphite is a covalent lattice, that means it consists only covalent bonds. Right. Question number 20. Question number 20. In which one of the following is the radius smallest? Radius smallest. That means smallest in size. Remember, if you, okay, I'll give the summary for that also. If you take cation, okay, I'll put one example. Cation is smaller than its atom. Cation is always smaller than its atom. I'll give one example. Sodium ion is smaller than sodium atom, because sodium ion has 2,8 or 1s2, 2s2, 2p6, like you have done the configuration. So this is that means number of energy levels in Na plus is less, that's why small. Cation is always smaller than the neutral atom, that is one condition here. Second one you can write, if you take the radius, that is called anion. Anion is smaller. Anion is always smaller than, so larger. Anion is always larger than, even in the previous one I put always small, right? Always larger than its atom. Anion is always larger. Example, Cl minus greater than Cl. Then third one you can write, we can easily prove this by looking at the configuration. If you write the configuration, number of cells, when electrons are added to an atom, it increases in size. When electrons are added to an atom, it increases in size. When electrons are removed from an atom, it decreases in size. That's the theory behind this. Okay, please copy down. And the other most important thing, anion is all. And the other most important thing, when the charge of the anion increase, size increase. So write the third point now. When charge of the anion increase, when charge of anion increases, what happened? When charge of the anion increase, anion is negative ion. 2 minus become 3 minus. What will happen? When charge of anion increase, what happened to the radius? Radius also increase. Radius of the anion increase. Is that clear, everyone? When charge of the anion increase, its radius of also increase. Did you all finish copying down? Then one more thing you can write, opposite. When charge of the cation increase, size decrease. When charge of the cation increase, I'll write the fourth point here. When charge of, okay, I'll give example for this one also, the previous one. When the charge of the anion increase, look at the screen. N3 minus larger than O2 minus. O2 minus larger than F minus. So that's nitrogen oxygen fluoride. This is charge higher, size also increase. Directly, like kind of when charge increase, size also increase. That's what it means. But that is anion, anion. But cation is different. When the charge of the cation increase, please write down that separately. I don't know if they have learned this in the theory class or not. Anyway, if you have not done learn this set, because anyway unit 1 everyone of you have done, then you know the ionization. So right here, when charge of cation increase, charge of cation increases, what happened? When charge of cation increase, its size decreases. Got it? I'll give one example. Na plus, I'll give these three examples I'll take. Who is smaller than? Na plus, Mg plus, Mg2 plus and Al3 plus. Who is small? When the charge increase, size decrease. So therefore this is the smallest one. Al3 plus will be the smallest one. Na plus will be the largest. Greater the charge is smaller the size. of cation, cation. It is valid for cation, not for the anion. Very important. This is valid for the anion. Anion and cation highlight if you want. Is that clear, everyone? These 4 points very important. But when you compare this, they should belong to the same period. Otherwise, you have to consider that also number of shells. Shall I erase this? Anyone still copied down this? Okay, I'll erase. If you are still copied down this, please raise the hand. Now you can easily get the answer. For question number 720, sorry, question number 20, some of you have already posted the answer. Very good. Let's see your answers now. Ransul is asking a question. Sir, how can we easily find when there are atoms or the ions of different periods? They will not make it more complex like so that you cannot find it at all. They will give one like a pattern should be there in among the four. Otherwise, you can't memorize this. You are given the periodic table. By looking at the position of the element in the periodic table, you can roughly decide. By looking at the position of the elements in the periodic table, whether it's plus charge or minus charge, you can easily decide that. Let's see answers now. The smallest in size will be the positive one. Always remember, the smallest in size means what? Radius smallest means what? It has to be a cation with greater charge. Cation with greater charge. Right? Cation with greater charge. So which cation has greatest charge, highest charge? Mg2 plus. Potassium is large. Group 1 bottom. Sodium and potassium. So then what is the answer? Yes. 20th. At least now when I explain halfway through you should be at least you should be able to post the correct answer. Those who have not done, after my explanation, try to put the answer to the chat. Otherwise, I don't know whether you have understood this or not. That's why I'm asking you to put the answer. Okay, so radius smallest what? Cationic radius is anyway smaller than atom, then it should be positive charge ion. Which one has higher positive charge? Mg2 plus. Answer is fourth. Chaniti correct. Ransiluni correct. Only Chaniti and Ransiluni posted the answer. And Sainab, you put the first answer. Anions are Sainab, anions are larger, right? Radius of the anions larger than cation. That also you can write here. Cation, the radius larger than anion. Number 5, I'll put a separate point here at the bottom. If they belong to the same period only, this is valid. I'll put separately at the bottom. Size of the cation, but in the same period, cations are smaller than anion. Is that clear? Cation is always smaller than anion if they have the same number of electrons, like approximately, right? Then so that is 20th one. The answer is Mg2 plus. Okay, if few of you have posted the correct answer to the chat. Mg2 plus. Next one, question number 21. I'll erase the screen. Question number 21. What is the answer? This is, remember, ABCD type question. In your A-level paper, even on the new syllabus A-level chemistry paper, you get 50 MCQs. A-level chemistry paper, you get, I don't know how many of you. Please raise the hand those who know the structure of the paper. Please raise the hand those who are aware of the structure of the paper. The structure of A-level paper. Only 2 of you. Because when you join the paper class, you should know the structure of the paper also anyway. Only Jagath. Right, let's see. Only 3 of you. So you are get, okay, I'll quickly brief like in 1 minute. You get 50 MCQs. Chemistry paper A level. You get 50 MCQs. So you get 50 marks. 50 MCQs, 50 marks. Out of these 50 MCQs, the first 30, 1 to 30. 1 to 30, you get 5 answers. 5 choices. You have to select one of that. Right. Then 30 to 31 to 40. 31 to 40 you get like this. What is ABCD type questions. ABCD type questions. Here are 10 MCQs. The last 10 MCQs it will be like this. 41 to 50. Our syllabus there was 60 MCQs, now it's reduced to 50. 41 to 50. But remember, the last 10 is more harder than ABCD type 1. That is called statement questions. Hardest type. The first statement, second. I have given like from that also some MCQs. I think in this paper or the next paper. Statement questions. Understood? So now they are doing this one. ABCD type question. So how it become hard? Sometimes only A and B correct. Sometimes ABC correct. Sometimes ABCD all are correct. Sometimes ABCD all are wrong. Sometimes only A and C correct. You can have different combinations. To match with all these situations, conditions, they have gone table. If you mark the first answer, that means AB is correct. If AB correct, first answer. If BC correct, second answer. If CD correct, third answer. Right? If A and D correct, first answer. Then now you can check the that is how you decide it. Fourth. Any other choice, answer will be 5. Any other option. That's why it's given there, right? Any other combination, fifth answer. So all 4 can be correct, all 4 can be wrong. Then the answer is 5, right? So if any other combination other than that. So therefore this also you should get familiar with this type of questions, because you are definitely getting 10 MCQs. 31 to 40 MCQs come from this lesson. I mean the statement questions. Then let's see the answer for this one. ABC type questions. How many MCQs you are getting? 10 MCQs, huh? 10 MCQs you are getting from this, like ABC type. 1 to 30, it's like one of the 5 answers you have to select. Then question number 21. Regarding the graphite, let's see. Please, I mean, you can put A, B, O, B, C like that, or else you can look at this table, the instruction given, and you can post the answer. Whatever the convenient method, you can post the answer. Okay, if you can't remember that, so I have given in this table A, D correct, answer is 4th like that. So then you can just put 21-4th answer like that. Okay, let's see one by one. Not true means incorrect. Not true means incorrect. So I don't know how many of you check for the correct one. They are asking incorrect statement. Okay. All the carbon atoms in graphite sp3 hybridize. Please raise the hand those who have done the hybridization. Please raise the hand those who have done the hybridization theory. Hybridization theory done. Right, okay, good. Except 2 of you are not. Now, if you take graphite, look at the screen. Graphite around 1 carbon atom, you had learned this in O-level chemistry also. Graphite around 1 carbon atom, there are 3 bonds. There are 3 bonds. Okay. So 1 electron left. 1 electron left. Carbon 1s2, 2s2, 2p6, 3s2. Sorry, 2p6. 2. Yeah, 2p4, sorry, 2p4. So outermost shell has 4 electrons. Right. Most of you put the answer, very good. 20th one, most of 21st, I think only 2 of you have posted the answer to the chat. Right. Let's see. So there are 4 valence electrons. there are 4 valence electrons. Now carbon atom, actually this is sp2 hybridized. To make, okay, I'll write here, there are 2 electrons here, and here there are 4 electrons. 1 2 3 4, like this. Now for the hybridization, to make 3 bonds, you need how many unpaired electrons? 3 unpaired electrons. 3 unpaired electrons. So, right. Those who have not done the hybridization, they will find it a little difficult, but anyway, I'll explain this. It should be 2p, no, sorry, it should be 2p2, sorry about that, 2p2. That should be 2p2, right? Sorry. Because the carbon atomic number 6, only 6 electrons. 1, 2. So what happened now? To make 4 unpaired electrons, 1 is shifted here. Then what happened? You will get 4 unpaired electrons. 4 unpaired electrons like this. To make 3 bonds, these 3 bonds are identical. In graphite, these 3 bonds are identical. Again, this will form like this. So I'll take, I'm interested about this one atom. I'll take this carbon atom in the graphite around 1 carbon atom. There are 3 covalent bonds. So to make 3 bonds, no need to get mixed 4 electrons. Only 3 electrons enough. Only 3 electrons enough to form 3 bonds. Only these 3 will mix up. Then we call it what? 1 from S, 2 from P. Then we call it sp2 hybridization. And this one remain unhybridized. 1 electron remain unhybridized. So this one I'll highlight. This one remain unhybridized. So this is called sp2 hybridization. So to make 3 bonds, 3 unpaired electrons combine and separate. Example, you have 1 banana and 2 apples. Now you want to share this with 3 individuals, 3 of your friends, to give the same quantity, same taste. You can't give 1 banana to one friend and the other 2 apples you can't share with the other 2 friends, because then they'll get different taste. So all 3 bonds are identical. They should get the same properties. All 3 bonds are identical. To have 3 identical bonds, they should be equal in energy. To have equal energy, then it's like making a fruit salad. So what is the best thing now? You cut the banana into small pieces. 2 apples also you cut into small pieces and mix and put into 3 separate cups. You understand what I'm saying? Then what? Everyone will get the same amount, same taste. So this cup also contains both banana and apple pieces. So the second cup also, that then you give to your 3 friends, 1 cup to each friend. Is that clear? So this is something I can easily explain hybridization. Hybridization, one requirement is what? To make identical bonds with approximately with equal energy. Therefore, 1 electron remain what? This is non-bonding electrons. These non-bonding electrons can conduct electricity. These non-bonding electrons in the valence shell important for the electrical conductivity. Is that clear? That's why graphite conduct electricity. I'll put a dot here. That is the non-bonding electron. The other 3 electrons are involved in the bond formation. sp2. This is sp2 electron. This is also sp2 electron. The other electron come from the other carbon. This is a carbon atom also sp2 hybridized. I'll put a blue dot here. So this side blue dot, this side blue dot, this side blue dot. That is for the adjoining carbon. Exactly, that is for the adjoining carbon. So the 3 red dots for the middle carbon. Central. I'll put this also red. Is that clear, everyone? So each carbon atom is what hybridized? sp2 hybridized. If you show the arrangement here, the hybrid orbital, it looks like this. Like this, one hybrid orbital, this is the other hybrid orbital, this is the other hybrid orbital. So then it will overlap with, I'll put this one red. Like this. And this is the other one. Okay. And adjoining carbon also, what happened? There's a sp2 hybridized orbital, sp2 hybridized orbital. That will overlap with this. And then you get the covalent bond. Like the same thing happened to the other three also. Like this. This happened to the other three also like that. So this is sp2 and this is sp2. sp2 is head to head overlapping. Result is covalent bond. So this electron remains free. Non-bonded electrons remain free to move. Remains free to move. That is called conduction electron. That's why the graphite conduct electricity. So graphite conductor of electricity. Graphite has high melting point. And graphite, what is the hybridization? Not sp3. sp3 hybridization, if it's going to make, that means it's like mixing one banana and 3 apples. If you're mixing 4 fruits, you have to make 4 cups. Here, 1 banana and 3 apple. That means you are mixing 4 fruits. 4 fruits if you are mixing, you have to make 4 hybridized cups or 4 fruit salad cups. 4 cups you have to make. That means then there must be 4 bonds around that. Is that clear? Now here only 3 cups mix. If 3 cups are mixed, you have to make 3 orbitals are mixed. Then what happens? You get 3 hybridized orbital. The name of the orbital sp2. sp2 means what? 1 from s orbital, 2 from p orbitals mix up to make 3 hybridized orbital. Is that clear? From the hybridization name, you can decide how many orbitals involved in the hybridization. 1 from s orbital and 3 from p, 2 from p orbital. Then how many cups you have to make? You have to make 3 cups. Right? If number of hybridized orbital form depend on the number of hybridized or atomic orbitals involved for the hybridization. It's like number of fruits involved equal number of fruit salad, the number of cups made. 4 fruits combined can be same type or different type. If 4 different types of fruits combined, you have to make 4 cups. If 3 fruits combined, 3 cups. If 2 different fruits combined, then you have to make 2 cups. That means 2 ones. Is that something similar to that? Any question? Any question? Is that clear? I think some of you have not done the hybridization. That's why I explained a little bit. This is the requirement of hybridization. CH4. I'll tell one example now. CH4, how to decide this? CH4, there are 4 identical bonds. Right? Now, when it comes to the, you had done, right? Hund's rule and Pauli's exclusion principle. Right? Aufbau principle you had done, right? Configuration, that is a very basic now. At the beginning you are doing this. So if you take CH4, what happened? There are 4 identical bonds around carbon atom. All four bonds are identical. To make 4 identical bonds, can you have this one? 2 from here and 2 from here. So they have different energy, different size, the shape of the orbitals. So outermost 4 electron. These 4 electrons can form bonds. Outermost shell 4 electron. These 4 can form bonds. The problem is what? They have slightly different energy. So you need, so I got here 2p2. So what happened now? They separate. So one is shifted here. Then you get here 1 electron here and 3 electrons here. Now they get unpaired first. So the paired electrons difficult to form bonds because already full. This orbital, s orbital can accommodate maximum 2 electrons, is full. So in that way it cannot make 4 bonds. Therefore before the bond formation they should be unpaired. Before the bond formation they become unpaired electrons. Unpaired electrons only going to form the bonds. After that they can get paired. If they are already paired, they can't form the bonds. If they are already paired, they can't form the bonds. Before bonding they should become unpaired, unmarried or singly occupied people. So these 3 singly occupied, but they have slightly different energy, different shapes. But in CH4 tetrahedral geometry, all 4 bonds are identical. All 4 bonds have the same bond length, same energy. Now how to make this 4 equal electrons for energy approximately equal equal in energy, you make a fruit salad, 1 from S and 3 from P. So then we call it what? sp3. sp3 means there must be 4 cups form here like that. Around carbon there are 4 equal cups, right? There are 4 equal cups around carbon. That means equally shared. The fruit salad, the same taste, same size, same amount, right? Then this is what this circle, hydrogen. Hydrogen is 1s orbital, and hydrogen is 1s orbital. Hydrogen is 1s orbital. Its atomic orbital, and hydrogen 1s1. So therefore, this is how the CH4, each CH bond is formed. sp2 hybridized orbital of carbon, sp3. sp3 hybridized orbital of carbon linearly overlap with 1s orbital of hydrogen. sp3 hybridized orbital, sp3 means what? 4 orbitals, altogether 4 orbitals involved for making the fruit salad. If 4 orbitals involved in for the hybridization, you have to make 4 hybridized orbitals. So write, if you want, in your short notebook, number of hybridized orbitals produced equal to the total number of atomic orbitals involved for the hybridization. If 2 atomic orbitals involved for hybridization, then you get 2 hybridized orbitals. If 3 atomic orbitals involved for the hybridization, then you get 3 hybridized orbitals. Hybrid orbitals, number of hybrid orbitals equal number of orbitals involved for this hybridization. So those things are basic things, you should remember that. Okay, is that clear now? So in therefore CH bond, each CH bond you can nicely explain. So this contain what? sp3 from carbon and 1s from hydrogen. Head to head overlapping. Head to head overlapping. Is that clear? So which statement are correct now? Out of this, which ones are correct? Yes, all the carbon atoms in that is, first one is A is wrong. A is wrong. I'll put a cross. Conductor of electricity, that is correct. Just because that you can't tell it's a metal. Just because that you can't, carbon is a non-metal but it's a conductor. Then can this A-level past paper question? This also A-level past papers 1990s, as I remember. Carbon has high melting point, that is correct. Why? Because it's a lattice. It exists as graphite and diamond. Then it is used as a fuel. No, carbon is not used as a fuel. Graphite is not used as a carbon. There are all carbon, some forms of carbon used as fuel, but graphite is not used as a fuel. It is not used as a fuel. So you have to put a cross for that. This one you have to put a cross. Used as a fuel. Graphite will never use as a fuel. Graphite, not coal we use, but not graphite. High melting point graphite, correct. Conductor of electricity, graphite, correct. All the atoms sp3 hybridized, wrong. So the answer is B and C. B and C means what? Answer is 3, no? Sorry, 2. B and C means answer is 2. Answer is second. Right. Let's see your answers now. Question number 21. Answer is B and C. A and B, B and C, answer is second. Sorry, they are asking, not true. We have to be very careful. Incorrect one they are asking. Sorry. Incorrect one is A and D. Incorrect one is A and D. Because of this arrowhead, I didn't see that. Incorrect one, not true regarding graphite. A and D wrong. That means answer is fourth. A and D correct. A and D will be the answer. No, then the answer is fourth. Chamika correct. Chaniti correct. Very good. Excellent. And Zainab correct. And Dulshan also correct. Dulshan, first you put fifth answer and then change to fourth. Good. Anyway, you have understood that. What about okay, the others reply, no? Chaniti, Zainab, right? Okay, very good. Then let's move to the next question. Question number 22. Strong hydrogen bonds. Strong hydrogen bonds exist in what? Ammonia. Yes. Okay, can you quickly post the answer first? Can you post the answer to the chat? Liquid ammonia, liquid HF, liquid acetic acid, CH3COOH, and liquid methanol. Sorry. Yes. Alcohol This is alcohol. This is carboxylic acid. Carboxylic acid. Carboxylic acid. And this is HF. HF anyway you have learned hydrogen bond in present. Ammonia also hydrogen bond in present. Okay, some of you have put the question number 22. Chanitha put fourth answer, Dulshan put third answer. Fourth means A and D, third means C and D. Yes. What about the others? I think some of you have not done the intermolecular forces, and maybe then you will find it a bit difficult. Anyway, answer is 5, because hydrogen bonds could be present in all this. Strong hydrogen bonds could be present in all this. Right? HF has hydrogen bonds because OH, NH, HF group, NH, all these contain hydrogen bonds. Okay. So they are strong anyway. You can't like weak and strong, but anyway it's approximately all these contain hydrogen bonds. Otherwise you can have only HF. That is the strongest one, highest electronic difference. Answer is 5. Question number 22, answer is 5. Right? Question number 23. You have learned sigma bonds and phi bonds, right? When there's a single bond, is always if there's only one bond, it is always sigma. Okay, I'll write here in a single bond. I'll make a table like this. Then you can copy down this quickly. Then you can easily get the answer. Look at the screen. Right here, number of bonds. Then sigma of 5 bonds here. Right. Look at the screen, everyone. When there's a single bond, it's always sigma. If there's a single bond, it is always sigma bond. Second one, you can write when there's a double bond, one is sigma, the other one is phi bond. One is sigma and the other one is phi bond. And when there's a triple bond, say I'll give one example, HH example. Double bond you can put OO like that. Triple bond I can put NN like this. So what happened in a triple bond? First bond is always sigma and the other two will be phi bonds. Is that clear? And the other most important thing, sigma bonds can be formed. Shall I erase this? Question number 23, I am explaining that this is one important thing. So there are two types of bonds now, sigma bonds and phi bonds. Please raise the hand those who have learned sigma bonds and phi bonds. Please raise the hand those who have learned sigma. Okay, okay, all of you have learned, right? So then the other most important, which orbitals could participate for formation of sigma bonds and phi bonds. Okay, I will write that also separately. For the these are the possibilities when making sigma bonds. Sigma, shall I erase this? Anyone still copying down this? Shall I erase this? Anyone still copying down this? Right, I'll erase this. Okay. Let me give you this also. When there's a sigma bond, these are the possibilities. S orbital, okay, number of orbitals involved here. I'll write When forming the sigma bond, the number of orbitals that could involve when forming the sigma bond. Sigma bond and phi bond. Okay, sigma bond and phi bond. One possibility you can write, sigma bond could be formed s orbital and s orbital. That is one possibility. S orbital and s orbital all result sigma bond. Second one, number 2, s orbital plus p orbital. That also will result sigma bond. Third possibility, s orbital and hybrid orbital. S orbital and hybrid orbital. This is p, this is p. I'll write here within bracket p orbital. This is p orbital. This is hybrid. Fourth possibility, s plus s sigma bond. S plus p orbital sigma bond. Always, always. S plus hybrid always. Then hybrid plus hybrid orbital. Hybrid orbital plus hybrid orbital. So I'll put here hybrid hybrid. That also results sigma bond. Don't mix up this with p orbital. P orbital and this is like a small. This side is bigger than the both side equal p orbital. This side it's like a fish here, right? Then next one, number 5. Number 5 you can write s orbital hybrid, then p orbital and hybrid orbital. Right? Hybrid orbital and p orbital also can result sigma bond. Always hybrid orbital and p orbital. So this is p, p orbital. That results sigma bond. Please copy down this in your short notebook. S orbital always sigma. S plus p orbital, S plus p orbital sigma. S plus hybrid orbital sigma. And there's one more possibility, pp overlapping, pp orbital, like this. Number 6 I put p orbital. 2 of the p orbitals can overlap, linear overlapping. What is called linear overlapping? Linear overlapping. Linear overlapping. Right. Linear overlapping. Is that clear? Okay. Sigma bond and phi bond. Phi bond, the only one instance phi bond possible, that is p orbital lateral overlapping. That is the only instance phi bond could be formed. pp lateral overlapping. P orbital lateral overlapping. P plus p lateral overlapping. Like this. So example you can get like this kind of overlapping, lateral overlapping. So that is the only instance where the phi bond is formed. All the other instances, SS sigma bond, S plus p orbital sigma bond, S plus hybrid sigma bond, hybrid sigma bond, hybrid orbital and p orbital sigma bonds, and pp linear overlapping also. This is p, pp linear overlapping also sigma bond. Sigma bond. Any questions? If you want, you can put a stand, right? Hybrid orbital will never form phi bonds. If you want to write, put a star right here. Hybrid orbitals and s orbital never form sigma bonds. Again, I am telling, hybrid orbitals and s orbitals never form sigma bond. Sorry, 5 bonds, not sigma. Sorry, 5 bonds. I'll erase here. So these should be 5 bonds. Never form 5 bonds. Again, I am right. S orbital and hybrid orbital never form 5 bonds. Never. If this is that clear? Now you should be able to, everyone should be able to give the correct answer for the 23rd MCQ. Only Dulshan and Ransiluni and Chaniti gave the correct answer. Shall I erase this? Anyone still copying down this? Okay, I'll erase this now. If you are still copying down, please raise the hand. I'll display that, right? So then you can easily get the answer for this. Overlap of p atomic orbital, 5 bond is always formed. Always? No. P atomic orbital can form both 5 bond and sigma bond. Therefore, this is, because of always word is wrong. P atomic orbital, 2 p atomic orbitals can form sigma bond if it is head to head overlapping, and if it is lateral overlapping, it can form 5 bond also. Therefore, A is wrong. Next one. Overlap of s orbital and p orbital, a sigma bond or 5 bond can be formed. Never. Right? I told you, if s orbital involved, definitely it should be always sigma, not 5. So therefore, this is also wrong. S orbital and p orbital, sigma bond or 5 bond, wrong. Can't. Only sigma. S orbital will never participate to form 5 bonds, always sigma. And then C, overlap of 2 s orbitals, a sigma bond is always formed. That is correct. 2 s orbitals will never form 5 bond, always sigma. That's correct. C is correct. Overlap of 2 s orbitals, a sigma bond is always formed. The next one, S and p orbitals taking part in the hybridization should belong to the same atom. S orbital and p orbitals taking part in the hybridization should belong to the same atom. Yes, hybridization, all the orbitals involved in the hybridization should belong to the same atom. You can't take one atomic orbital from fluorine and the other one from hydrogen, can't. So they should belong to the same atom. Okay. So it's like this. If you are mixing fruits, only fruits you should mix. So all the curries left you don't mix in the kitchen. So all the fruits you can mix and you can make a fruit salad. Sometimes if you have 2-3 curries, like sometimes we call in single hat malwa wale, whatever. So you have a little bit of curry left with say maybe dal curry, little bit of dal curry left with maybe leeks curry. Then you can mix those two. Both are vegetables. Both belong to the same category, like that. Or both are fruits. But fruits and vegetables you are not mixing, right? I don't think. Right. So therefore, all the orbitals involved in the hybridization should belong to the same atom. So therefore, what is the answer now? They are asking incorrect one or correct one? Correct one, right? Then the answer will be C and D. Answer is 3. Very good. 23. Answer is 3. Ransiluni correct. Chaniti correct. And Dulshan correct. Very good. Dulshan, earlier you have put 5th answer. Now change to 3. Good anyway. It's okay if you first you guess the incorrect answer and later you understand with my explanation, and again you can post the correct answer, no problem. Then at least I know you have understood it. Right. Shall I erase this? Right. Then next one, question number 24. 24. Radiations have higher energy than visible rays. Wait, question number 24. I think you had done the electromagnetic spectrum, right? Chapter 1. Which one has the higher energy than visible rays? After visible light, which one is? Yes. Higher energy than visible rays. There are two, right? Microwave below visible electromagnetic spectrum. Even all the students can give the answer for this. This also error past papers. X-rays and UV. Both this above visible light, above after violet, ultraviolet. Then after that you get X-rays. Answer is only B and C. That means what? 24th answer is second. Very good. A and B, B and C. Yeah, B and C. B and C means second answer. Very good. Chaniti correct. Dulshan correct and Ransiruni correct. Question number 25. Which will contain protons? So we have done about alpha, beta, gamma, right? I mean, and cathode rays, positive rays we have done. So the hydrogen contain protons. Beta rays equal to what? Electron. You can write below beta rays, you can write electron. Alpha rays, it's He2 plus. So that contain proton. So alpha rays contain proton. Cathode rays, electron. Beta rays, electron. Positive rays contain proton. So answer is only A and D. A and D. Alpha rays and positive rays contain protons. Answer is A and D means answer is fourth, no? 25 answer is fourth. Very good. Chaniti correct. Ransiluni correct. Dulshan also correct. Dulshan, you have put the 24th. 24. Right. Yeah, 25. Okay. 25th one. Right. Okay, Dulshan. Right. Yeah. Good. Then question number 26 regarding ionic compound. Question number 26. True statement regarding ionic compound. Can you quickly post the answer to the chat? They have higher boiling point, yes. They conduct electricity in all three physical states, wrong, no? Solid state, they don't conduct electricity. Solid NaCl can't. So I'll put a right tick for this one. A correct. B wrong. Because of all three physical state is wrong. Because of all physical state. So you can write here within bracket why is wrong. Solid state, solid doesn't conduct electricity. Solid form of any ionic compound, solid form cannot conduct electricity. Then C will be, they will be dissolved due to ion induced dipole interaction in water. Actually, I don't know how many of you have done this. That's correct. Ion is Na plus or Cl minus. No, that is wrong. Can't be induced dipole. This should be dipole. In water, ion, please write the ionic compounds NaCl dissolves in water because of ion dipole, not ion induced dipole. Because of induced word is wrong. If they have given ion dipole, then is correct. Because of induced word, that's wrong. Because ionic compound, right? Then C is wrong. D, the strongest electrostatic interaction in compounds will appear in, yeah, strongest electrostatic interaction in compounds will appear in ionic compound. That is correct. The answer is only A and D. How many of you got the correct answer? A and D only correct. What is the answer? 26. Okay. Someone is asking about what is induced Dulshan. Okay, I'll explain. I don't know how many of you. Please raise the hand. Those who have learned about secondary interactions. Dipole, ion induced dipole, hydrogen body, like that. Secondary interactions. Those who have learned, please raise the hand. Under bonding lesson. Bonding lesson, primary interactions and secondary interactions. Only Chaniti. Okay, I'll give summary for that. Okay, don't worry, I'll give summary. I will use the Zoom whiteboard in this easy. I have more space. Okay, look at the screen. You can see the screen again. Look at this. Now, look at the screen, everyone. So the bonding, there are two types, primary and secondary. Right? Bonding, there are two types, primary and secondary. Bonding, there are two types, primary and secondary. Primary interactions. Under primary interactions, you get you will actually the paper class, you will get some of very useful short notes. I will not tell all this again and again. Once I the things that I have already given, I won't tell again. Therefore, you should better quickly copy down these primary interactions are known as, there are three types of primary interactions. Number one, covalent bonds. Number two, ionic bonds. Number three, metallic bonds. Metallic bonds. Right. Then secondary interactions. These are the secondary interactions. Actually, sometimes in your oral chemistry, you learn that intermolecular forces, that is secondary interactions. Secondary interactions. Secondary interactions. Secondary interactions are also known as intermolecular forces. Intermolecular forces. Intermolecular forces. This is sometimes called intra. This one is known as intramolecular forces. Within the molecule, intramolecular forces. Intramolecular forces means within the molecule. Inter means between molecules. So is that clear, the difference now? Intra and inter. Intra means within, inter means between molecules. Between molecules, intermolecular forces. Between molecule, inter. Between two cities, intercity, like that. Now intermolecular secondary interactions, these are the ones. Number one, I'll put them in the correct, the strongest to lowest. Strongest to lowest, I'll put them in the correct order. Then it's easy to remember. Most strongest secondary interactions, intermolecular force, will be iron dipole. Iron dipole. I'll give one of the best example. Sodium chloride contain ions, and water contain dipole. That means two poles. One pole is positive, the other pole is negative. H plus, the positive pole, O minus, negative pole. So that is called dipole. So between this dipole and the ion, there's an attraction. That attraction is known as iron dipole. Between an ion and a polar molecule. That is what? Between ion, as example, I'll erase this later if you can quickly copy down this. If you dissolve NaCl in water, delta plus and here delta minus. So delta plus attract what? Cl minus. Delta minus will attract Na plus. The oppositely charged. Na plus surrounded by oxygen atom, Cl minus surrounded by hydrogen atom, because of this oppositely charged. So this is the iron and this is the dipole. Between iron and dipole means there are two poles, positive pole and the negative pole. That is called di. Di means two, pole means two poles, like north pole and south pole, like that, oppositely charged ends. So between this dipole and the iron, the interaction called iron dipole interaction. Is that clear, everyone? Is nothing, even all students can understand this. Iron dipole interaction. But in oleochemistry, you learn just intermolecular forces, so intermolecular bonds. Is that clear? Right. Now, I will erase this one. If you want, you can copy down the detail like how it is arranged. Then second strongest one, I'll write hydrogen bonding. Hydrogen bonding. Second type of its secondary interactions, hydrogen bonding. Hydrogen bonding present in HF, HCl, sorry, H2O, NH3 like that. In this HF, H2O, NH3. So they have between water and even hydrogen bonds basically the molecules contain HF, OH and NH bonds. Contain hydrogen bonds. That means it's a type of dipole-dipole. Both the ends are pole. Dipole-dipole interaction. A special type of dipole-dipole interaction. Then third one, dipole-dipole. 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 Say example HCl. Dipole-dipole. Between two HCl molecule, dipole-dipole. That means this HCl polar, delta minus, delta plus, and the other HCl molecule also polar, delta plus and delta minus. So between these two, then you get what? Dipole-dipole interaction. Dipole-dipole interaction. Is that clear? This is a dipole. This is also a dipole. Between these two dipole, the interaction called dipole-dipole. Therefore, HCl, even HCl dissolves in water because of dipole-dipole interaction. Right. Then someone asked about, so what is induced? I'll tell that also. Even okay, I'll write here between HCl molecule. This dipole. Then fourth one. Next strongest one. Iron dipole I give. Dipole. So you can write next one. Iron induced dipole. Iron induced dipole. What is iron induced dipole? Between iron, say NaCl, Na plus and Cl minus. Say I2 plus Ki. I2 is non-polar, Ki is polar. So in the presence of I minus, this get temporarily due to the influence of iodide. So imagine Ki, potassium iodide release I minus. I minus is the iron. Due to the influence of this iron, the non-polar one slightly get polarized into like delta plus and delta minus, not permanent one, temporarily. So this is induced by whom? Negatively charged ion will induce the poles on the I2 molecule. That's why Ki, iodine dissolves well in Ki. Actually, pure iodine is metallic black, gray, solid, pure iodine. Pure iodine insoluble in water. But pure iodine dissolves well in Ki. That is because of this secondary interaction. Therefore, secondary interactions will affect the water solubility also. So that I explained. Then iron induced. So this number 5 I'll write iron induced dipole. Then you can write dipole induced dipole. Dipole induced dipole, one of the best example. Dipole is dipole induced dipole. So I'll write here iodine plus water. Water has dipole and iodine dissolves in water slightly due to the dipole induced dipole. Induced dipole from iodine and dipole from water. Between water, hydrogen bonding. But water and iodine, you can't tell hydrogen bonding. Iodine and water, no hydrogen bonds. Then number 6. Induced dipole means someone asked about that question. So what is induced dipole? Induced means it is induced by the other party. Or I minus make the I2 to induce dipole. Right. Then next one, right? Induced dipole and induced dipole. Induce and induce. Sometimes we call this induced dipole is also known as sometimes dispersion forces. Or sometimes it's also known as London forces. So one of the best example, iodine plus, okay, I'll tell like this, induced dipole, you can write here CH4, both are non-polar. between CH4 molecules there can be a induced dipole. Or else you can write that means between non-polar molecules. Okay, I'll write within bracket. There are so many examples. Between non-polar molecules. Between non-polar molecule. I'll give a simple example. Please tell me why oxygen dissolve in water due to which of these interaction. Oxygen is non-polar, water is polar. I'm asking the question now. Oxygen dissolves in water because of which interaction? Oxygen is non-polar, water is polar. Oxygen is a non-polar one. So oxygen is non-polar, but it dissolves slightly in water, otherwise the fish will die. Because of which of the secondary interactions? Yes, who can tell me? Why oxygen is slightly dissolving in water? Because of there must be interaction between water and oxygen. What is that interaction? Which out of these six, to which one it belongs? Yes, any volunteers? Very good answer, Rene. Dipole induced dipole. Oxygen induced dipole. Oxygen is a non-polar molecule. Water is a polar. In the presence of a bad guy, good guy also become bad. Something like that. In the presence of water molecule, water has slightly negative and or slightly positive, and then this can become temporarily charged delta plus and delta minus. So oxygen can become like that. Is that clear, everyone? Between water and oxygen. And if you take between iodine and water, same scenario. Iodine is partially soluble in water. Iodine is non-polar. Iodine, its influence, dipole influenced by water. In the presence of water, iodine gets slightly polarized like this, delta plus and delta minus. Then it's become basically between non-polar and polar. It is induced dipole and dipole. Between non-polar and polar. If you want to write that way also here. Non-polar, polar. What is this called? Dipole, polar. Dipole come bit. I don't have space, otherwise I can write that also. Polar molecules. Right? Polar molecule, dipole. Then ion induced dipole means what? Non-polar and ion. Ion means not IRON ion, ION ion. Between any ion and non-polar molecule. Then the other one is polar molecule and non-polar molecule. Then you get iodine and water. Iodine dissolves slightly in water because non-polar polar interaction very weak. So if you can put an arrow downward and right, you can put an arrow downwards, right? What happened downwards? Polarity. The strength of intermolecular force increase. Strength increases. Strength decrease. Other way around. The strength decreases downwards. The strength decreases. Is right. Strength decreases down the group. Now, shall I erase this? Anyone still copying down this? Right. I'll erase this. Now you can answer the question easily now. I'll move back to the paper again. Okay, let's see the paper again. Okay, what is the question now? Regarding ionic bonds. So next time I don't explain that again, the secondary interactions. So here they have regarding ionic compounds. Right. True statement regarding ionic compound. They have higher boiling point, correct. They conduct electricity in all three physical state, wrong. All physical state wrong because of solid. Solid does not. Then they will be dissolved due to the ion induced dipole interaction. Ion, not induced dipole. Ion dipole. So that's why it's wrong. It is ion dipole, not induced dipole. What is pole? So B also wrong. C also wrong. D, the strongest electrostatic interaction in compounds will appear in ionic compounds. Strongest electrostatic interactions in compounds will appear in ionic compound. That is correct. Answer will be A and D. Question number 26. Answer is fourth. Very good. 26 fourth. Chaniti correct. Dulshan also correct. Ranceroni correct. Very good. 26 answer is A and D. Answer is fourth. Right. Done. Then question number 27. I will erase the screen. 27th MCQ. Which of the following deflected when moving across a magnetic field? Who can give me the answer for the 27? You had anode, cathode rays, anode rays, cathode ray experiment and everything. Yes. Deflected across a magnetic field. Remember what will be deflected across a magnetic field? When a charge particle, only charge particle, I'll put another, only charge particles will change the direction of the path. Only charge particles. Only charge particles. Right. So then what is out of this? What are charge? Photons are charged. Correct. Cathode rays are charged. Neutrons no. Helium atom uncharged. Atoms are uncharged. Atoms are neutral. Atoms are electrically neutral. Then what is the answer? Only B and C. Answer is second. Dulshan correct. Ramsiruni correct. Chaniti also correct. Very good. Right. Then question number 28. 28. Which of the following statement true about metals? About metals. I'll erase the screen. So 27 answer is cathode rays and protons. Only charged particles will show deflection. 28, who can put the answer? 28th MCQ, yes. Any volunteers? True statement about metals. A, they conduct electricity. Yes, any metal conduct electricity. Oh, there are nearly more than 80 metals in the periodic table long form conduct electricity. Yes. Then density of all the metals higher than that of water. Is that correct? B. Why B is wrong? What is the evidence? Sodium. Sodium floats on water. Sodium floats on water. Right? Sodium floats, so that's therefore it's wrong. Density. They react with dilute acids always. With always word, be careful. Now in the exam, always, mostly, sometimes, so we have to be careful with the. Why this C is wrong? Can you give me an evidence? Why C becoming wrong? They react with dilute acids always. One of the best example, silver, copper, platinum, gold, Au. They don't react with dilute acid always. Metals are not always. It's only some metals. Always, because of always is wrong. Right? Example, silver, platinum, copper. They don't react with dilute acid always. Majority of the elements are, this also LL pass question. Majority of the elements are metals. That is correct. Why? More than 80, nearly 88 elements in the periodic table are metals. Not only few non-metals. So what is the answer then? Yes, 28. Answer is only A and D. Answer is fourth. Chaniti correct. 28. Dulshan answer is fourth. Okay, right. Ansiludi, why did you put fifth? Dulshan also earlier gave the fifth answer. Right, did you understand now why the answer is only A and D? Then question number 29. 29th MCQ. Can you quickly post the answer to the chat? 29th MCQ. Yes. Sometimes within the first 5 MCQs you can get the similar question like this in the oral paper. This one. What is okay? If you take this one has 50 protons, right? 50 electrons. Neutrons will be what? 118 minus 50. What is that? How many neutrons? 118 minus 50. You get 68, no? 68 neutrons. Then let's see the answers now. It has 50 electrons, correct. It has 50 protons, correct. It has total number of 118 electrons and protons. Total 118. That is wrong. That is wrong. Then it has 68 neutrons. That's correct, no? 68 neutrons. That's correct. So the answer is 5, right? Because of look at the instruction given at the beginning. A, B, D correct means answer is 5. Right. 29 Dulshan correct. Right. Ran Siruni correct and Chaniti also correct. Very good. Question number 30. 30th MCQ. So you have to refer the periodic table. Can you quickly tell me the answer for the 30th MCQ? Which one has 5 unpaired electron? 5 unpaired electron. Chromium and okay. So if you take chromium, configuration check, and then you can easily decide that answer. Chromium, what is the atomic number? Chromium, nickel, iron and manganese. 5 unpaired electrons. You have to write the electronic configuration. You should go for the electronic configuration. Yes. Okay, if you take chromium, atomic number 24, right? Atomic number 24. So you get 3D5 5s1. Chromium it become outermost one only I will write 3D5 4s1 chromium. When it becomes Cr3 plus, what happened? It become 3D 3 4s not. So then outermost shell contain how many unpaired electron? Only 3. Only 3. Cr3 plus has only 3 unpaired electron. Cr has 6 unpaired electrons. Cr has 6 unpaired electron, but Cr3 plus has 4s not nothing. 3D3 D there are 5 orbitals. So we have only 3 unpaired electron. That is not there. Then next one, nickel. Nickel, what is the atomic number? Nickel atomic number is 28. So what is the configuration of nickel? Then you can go for Ni2 plus. 3D8 4s2. 3D8 4s2. Atomic number 28. When it become Ni2 plus, what happened is first 2 electrons 4s2 going out, then it's become 3D8 4s not 4s not. So these two are lost. So how to write the D8 here? 1 2 3 4 5. So 1 2 3 4 5 6 7 8. That means it has only 2 unpaired electron. It has only 2 unpaired electron. They're asking 5 unpaired electron. Then I'll go for the next one, iron. Right. So this CFE, iron. Iron, what is the atomic number? Atomic number 26. Atomic number 26. Then I'll write what? 1s2, 2s2. No need the inner shells. I'll write only the outermost shell. I'll write only the outermost shell. Iron, it's 3d6 4s2. Atomic number 26, d6 4s2. Outermost configuration 3d6 4s2. So how to, when it become Fe3 plus, how many unpaired electrons? How many unpaired electrons? So actually that is one answer. 2 gone from this and 1 gone from this. Then it's become 3d5 4s0. 3d5 4s0 means it has 5 unpaired electron in D. 1, 2, 3, 4, 5, like that. You get 3d5. 3d5. Then next one, that is one correct answer, one possible answer. This is correct, na? Manganese, Mn. Let's see manganese. What is the atomic number of manganese? Atomic number of manganese 25, no? Atomic number is 25. Then you can write what? 3d5 OS2. So you get directly 3d5 here. 3d5. Then you get 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You have done a Hund's rule. I am not going to explain this filling of orbitals, first electrons, parallel spin, unpaired electrons in parallel spin first, and after that only the pairing begins. Once all the orbitals occupied with single electron, the pairing begins. So now you got the answer, right? You got the answer now. That means what? C and D will be the answer. C and D will be the answer. C and D will be the answer. Is that clear? Answer is 3. Let's see how many of you got the answer. Question number 30. Ranchiluni correct, Chaniti correct. Dulshan, not the 5th answer. Answer is 3. Right. Okay. Is that clear, everyone? Shall I erase this? Anyone still copy down? Please raise the hand. Okay. Then next one, the hardest part, the statement questions. So because anyway you should practice all these types. There are not only 1 to 5 answers. So question number 21 to 30, I think I gave ABC type. The last one I have given the statement questions. If both are correct, and explain the first answer. If both are correct, does not explain second answer. True and false, third. False and true, like that. I mean, first statement and second statement you have to check separately, and then you have to find there's a relationship. Anyway, I have given the instruction above. Okay, let me. Okay, who can guess the first one? This is also from your general chemistry, or all of you have done this, right? 31st, can you quickly post the answer to the chat? Hurry up. Yes. 31st. Paddle wheel placed in the path of cathode ray rotates. Is that correct? Yes, that's correct, right? Cathode rays are negatively charged. That also correct. Cathode rays are negatively charged. So is there a relationship between these two? Will the second statement the reason for the first statement? No. There's no correlation between these two. The answer is both are correct, but there's no second statement is not explaining the first one, therefore the answer is second. If they explain, then if there's a correlation, then you have to put the first answer, right? Then true, but does not explain. Can you quickly post the tell me the answer for the question number 32? MCQ. Remember, the A level is that is one of the most competitive exam in Sri Lanka. If I ask, if someone asks from me, what is the hardest exam you have faced? I won't tell masters or my BSc or PG postgraduate. I'll tell my A level. That was the most difficult and tough. I work hard for A levels than any other exam in my life. So that is applicable even now to these students. Therefore, it really work hard, right? These 2 years. So you have to decide, work hard these 2 years and enjoy the rest of life, or enjoy these 2 years and suffer the rest of life. That is on your hand, not on your parents or the teacher's hand. Remember, therefore, from the beginning you have to work hard. Otherwise, you can't do magic in the middle. So every class is important. A level, what matters? Not the grade, not 3 years. Marks matters. That will affect your study score. Right. So if you can get A pass from 90s, that's better than getting 3A's each 75, 75, 75. Then sometimes there are students those who get 2A's 1B, but 2A's leading 90s, like marks 90s for the 2A's. Then even though that one get third subject say B pass, or sometimes might get entered to the university because of high study score from the other two subjects. Right. So I hope you understand what I'm saying. Therefore, what matters not only the grade, the marks. What matters? A level. Right. Question number 32. You had enough time. What is the answer? SF6 can form because that is a tetrahedral. Then sulfur is less electronegative than oxygen. That's also correct. Will that explain? No. Answer is second. Then atomic spectrum of hydrogen is line spectrum. Third three, actually the hydrogen spectrum I didn't discuss any questions before. So therefore I'll explain that, leave encircle this next week. I'll start with this one, I think. 33. Please remember that in your head. Atomic hydrogen diamond is a form of carbon electricity. 34th one, can we do? Diamond has giant star. This is correct. Diamond is an allotrope of carbon, which does not. That is also correct. That also doesn't explain, no? They're asking about allotrope of carbon. Right, done, no? Okay, good. Most of you done it well. Now some of the chances of why A level is hard, why local A level is hard, because our University Grant Commission or UGC use your A level results to select the students to the university. I think none of the other countries using A level results to select the students to the universities. They pass A level and the university do a separate entrance exam to select the students for the required courses. But in Sri Lanka, the A-level results are used by the University Grant Commission or UGC to recruit the students for the universities. So therefore, that's why now. Otherwise, if they pass, if they make the papers here also, they can make it easy and they can pass the students. Then university, they will keep a separate exam to select the students based on their performance. Because A level is very, very competitive in Sri Lanka, that's right, especially Western Province. Then question number 34 also I told, right? 34, diamond is an allotropic form of carbon. It does not conduct electricity. That's correct. No, it doesn't explain. Yeah, question number 34, it doesn't explain, right? Then question number 35 onwards, I'll discuss the next day. So it's already 10:30. I'll discuss next day question number 35 not. So please try to, I'll post one more paper before, like within tomorrow I'll post one more paper your WhatsApp, then both those, but anyway the first few papers I'll take little bit of time because some questions I'll explain bit in detail and give a summary note, short note, that will be more useful rather than just copying down the answer. Then we'll go for the questions. Right. Okay, then we'll stop for today. Good night and God bless you all. And stay safe.